Hello, this is Mr. Miller, and things are happening. We have video 28 today, and it's on Polygon angles. Let's get going. There's a formula that's going to be very useful for us to solving problems for Polygon angles. It's down here in the lower right corner. So this formula we got to get to know really well. To find the sum of the angles of a polygon, you got to do the number of sides minus 2 times 180. That's going to be very useful for us. Okay, so let's take a look at the first problem. Our first examples are missing angle problems. So in this first problem, it's a quadrilateral. So we probably don't need the formula for that. We know that the total angles of a quadrilateral are 360 degrees. So triangles, the angles of a triangle add up to 180, and the angles of a quadrilateral 360. So we got to take 360, subtract off the angles we have. What's left is the missing angle. So 360 minus 94 minus 135 minus 45 equals 86. So in this problem, x equals 86 degrees. All right, the next problem. This a little bit has more sides. So this one has 1, 2, 3, 4, 5 sides. It's a pentagon. So we need to find the total of the angles, or the sum of them. So the total is going to be 5, the number of sides, minus 2 times 180 degrees. And if you do that, you get 540 degrees. So after we do a bunch of problems, you'll probably remember quadrilaterals add up to 360 degrees. Pentagon angles add up to 540 degrees. So I'm going to start with 540 and subtract all the angles we have. And what's left is x. So 540. And let's subtract 79 minus 76 minus 59 minus that huge 263 degree angle in the middle, and we get x equals 63. So again, the secret's knowing what they add up to. All right, here we have a crazy shape. So let's count the sides. We got 1, 2, 3, 4, 5, 6, 7 sides. So the total of the angles is going to be 7 minus 2 times 180, which is 900 degrees. So we got to take 900, subtract all these guys. And it turns out, if you do that, you get 62. So for this problem, x equals 62 degrees. So you got to take 900, subtract every angle here. You can do it quickly on your calculator, and 62 is what you get. Let's move on to the second type of problem. Second group of problems involve regular polygons. A regular polygon is a polygon whose sides are all congruent and whose angles are all congruent. So regular polygons, we can do more than find the total. We can find the value of each angle. Okay, so the first one has 6 sides. It's a hexagon. So the total is going to be 6 minus 2 times 180, and that ends up being 720 degrees. That's the total. Since all 6 angles are the same, to find each angle, we do 720 divided by 6. And when we do that, we get 120 degrees. That's our answer. Okay, so each of these guys here is 120 degrees. This is an octagon. So first step, find the total. If you do 8 minus 2 times 180, you get the total for an octagon. All right, that one I didn't know. So the total is 1080. And if we divide that by 8, because there are 8 angles, each angle is 135. All right, save the easiest one for last. It's a triangle. The total angle of the angles of a triangle is 180 degrees. And if we divide by 3, we get what each angle is. Each angle of the equilateral triangle is 60 degrees. But that's what a regular triangle looks like. All the sides are congruent, all the angles are congruent. Okay, we don't necessarily need a figure. If we have a polygon with 12 sides, and it's a regular polygon, we can find the angles. So the total is going to be 12 minus 2 times 180, which is 1800. Then we got to divide that by 12 angles. So 1800 divided by 12 is 150. So each angle is 150 degrees. Okay, let's do this bottom one. Regular polygon has 18 sides. So the total is 18 minus 2 times 180. Okay, I got no idea. So let's do that. Ends up being 2,880. I knew that. All right, then we have to divide that by how many angles there are. 18 sides means there's 18 angles. And we get each angle is 160. These don't always work out to nice numbers. Sometimes they're decimals. Okay, we're ready for the last examples. Here we go, ratio problems. So the angle measurements of a quadrilateral have the ratio 1 to 2 to 2 to 4. Find the angles. Well, we're going to set it up like this. Just like when we're doing triangle problems. We're going to represent the angles with 1x, 2x, 2x, and 4x. X represents the number we're multiplying all these numbers by to get the angle measures. So sometimes it helps just to draw a sketch. It doesn't matter, just draw some old quadrilateral and label the angles. It just helps us. So when we add these up, we gotta set it to the total. So if you add those up, we get 9x equals the total, which is 360 for quadrilaterals. Divide by 9, and we get x equals 40. Okay, now we solved the problem. We did most of the work, but it says find the angles. So we have to put x into the expressions. 1 times 40 is 40, so that the first angle is 40 degrees. 2 times x is the second angle, that's 80. The next one is 80. And the last one, 4 times 40, is 160. Those are the 4 angles. All right, we made it to the last one. This one's a pentagon. It has 5 angles. And we're going to represent the angles as 2x, 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 3x, and 3x. Let's just kind of draw some sort of pentagon here. There we go. Beautiful, huh? Label the angles. Again, add them up, set it equal to the total. When you add those up, we get 12x. Total for a pentagon is 540. So when you do 540 divided by 12, you get 45. Okay, so now let's find the angles. 2 times 45 is 90. So the first 3 angles are 90. And they're all degrees, so I'll put degrees there. The fourth angle is 3 times 45, which is 135. And the fifth one is at 2. There we go. There are 5 angles of the pentagon. Time for the journal assignment. All right, the first problem, you got to find the missing angles. So you may need the sum formula to find the total. So start by finding the total. The formula is down here. So down here is the formula that we derived in class. So you may need to use that. So find the total of the angles of the polygon, subtract the given angles, you have what's left. The next problem is a ratio problem, and the final problem, find the interior angles of the stop sign here. All right, that'll do it. See you in class.